Good evening, everyone. Welcome to Career Launcher. My name is Naveen, and today we'll be discussing CSAT QA 2024 paper, and this is part one of the series. In this series, we'll be discussing the previous year questions. Okay. So the first question that we have is, what is the least possible number of cuts required to cut a cube into 64 identical pieces? So do remember that when we are talking about a cube, so you will have to write 64 as cube of a number. So this will give us the value of n as 4 because 64 is nothing but 4 cube. Now, once we get the value of n, then the minimum or the least number of cuts required is given as 3 times n minus 1. So this is going to be 3 times 4 minus 1. So this is going to be 3 into 3, which is going to be 9. Now, why does this happen? So basically, if we have a cube and if we make a single cut right here, it breaks into 2 pieces. So if you're going to make 1 cut, it will break into 2 pieces. If you make 2 cuts, it will break into 3 pieces. So if we have n cuts, it will break into n plus 1 pieces. So similarly, if we further break it horizontally or if we cut it horizontally, so initially when we made a cut, we had 2 pieces. And then when we made the next cut horizontally, we are going to have a total of 2 into 2, 4 pieces. Now, if we cut it along the third dimension, we will have another into 2. So this will result in 8 pieces. So the first piece is this particular cube. The second piece is the cube to the right of it. Then we have another cube which is below the previous one, another cube which is below the next previous one. So we can see that we have got 4 cubes in the front. And similarly, we are going to have 4 cubes at the back, out of which we can only see 3. The fourth one is hidden. So that is the reason why, in order to get least number of cuts, we need to make it 3 times n minus 1. So this 3 denotes the number of dimensions that we are cutting into. So the answer is going to be option B, which is 9. Next. A certain number of men can complete a piece of work in 6k days, where k is a natural number. By what percent should the number of men be increased so that the work can be completed in 5k days? So this is a question from time and work, where work is given as workforce, as in how many people are working, into for how long they are working. So if we talk about this particular problem, the work can be written as certain number of men, let's call it as M, they can complete a piece of work in 6k days. And the number of men now, let's call it M dash, it can complete in 5k days. So from here, we can calculate M dash upon M is equal to 6k upon 5k, which is going to be 6 upon 5. So that means if we compare here, we can say that initially there used to be 5 men working, and now there are going to be 6 men working. Now, if 5 men were working initially and now we have 6 men working, we can see that there is 1 more man that has been introduced out of those 5 men. So 1 by 5, it's nothing but 20%. So there is going to be 20% increase the number of men. So it's going to be option C. Next problem. X, Y, and Z can complete a piece of work individually in 6, 8, and 8 hours respectively. However, only one person at a time can work in each hour, and nobody can work for 2 consecutive hours. All are engaged to finish the work. What is the minimum amount of time that they will take to finish the work? So this is a scenario where individual people are working. We can calculate the total work as LCM of the durations that are given. So LCM of 6, 8, and 8, which is going to be 24. So we are going to assume that there are 24 units of work. After that, we can calculate efficiency of each person as total work divided by how much time they take. So in order to calculate efficiency of X, it's going to be 24 units that that X has to complete. But in order to do those 24 units of work, X will take 6 hours. So its efficiency is 4 units per hour. Similarly, efficiency of Y, it's going to be 24 divided by 8, which is also going to be same as efficiency of Z because Z also takes 8 hours. So it's going to be 3 units per hour. Now, it is given that, however, only one person at a time can work in each hour and nobody can work for 2 consecutive hours. And all are engaged to finish the work. What is the minimum amount of time that is required? So basically, since only one person has to work and we need everybody to work, so we will prefer that X should work as many times as possible. So basically these 24 units, X should work for 4 units. Then Y or Z will work for another 1 hour. So that will be another 3 units. Again, X is going to work and complete 4 units. Again, Y or Z is going to work. That's going to be 3. So right now we are at 7 plus 7, 14. Again, X will work and finish 4 units. Again, Y or Z is going to work, will finish 3 units. So this is 21 so far. And then again, X should work. And X is supposed to finish only 3 units left. So since this is 21, we need another 3 from here. So for how long should X work? Let's say D is the duration. So 4 into D should give us 3. So D is going to be 3 by 4. So that means X should work in the last term for 3/4 of an hour, which is 3 by 4 into 60, these many minutes, which is going to be 3 into 15, which is 45 minutes. So basically, the work will get completed in the minimum time, which is going to be 3, 4, 5, 6 hours and 45 minutes. So option C becomes the answer. Now, why is that we are always taking X to work more number of times? Because X completes rather more units as compared to Y or Z. So if Y or Z work for 1 hour, only 3 units will get completed. If X works for 1 hour, 4 units will get completed. Since we need to find the minimum amount of time, we'll prefer X to be working more. Next, how many consecutive zeros are there at the end of the integer obtained in this particular product? Well, the number of consecutive zeros at the end of a particular product, it's given as the number of 2's and 5's we are supposed to have. Now we can see that the number of 2's are going to be a lot. So we have to count number of 5's. So the first 5 we will have is 5 to the power 5. Then we will have 10 to the power 10. Then we will have 15 to the power 15. Then we will have 20 to the power 20. And then we'll have 25 to the power, it's the even power. So 5 to the power 10, 20, 30, 40, and 50. So 5 to the power 10, 10 to the power 20, 30, 40, and 50. Right? So whatever is the base as the number, the power is 2 times of that. So if it is 20, the power is 40, as we can see in the pattern. Now, how many 5's we are going to have? Now, 10 is made up of a 2 and a 5. So we will only consider a 5. 15 is made up of 3 into 5. So we will consider only 1 5. 20 is made up of 1 5 again. So we'll consider that 5. But 25 is basically made up of 5 square. So we will consider 2 5's here. So the total number of 5's we will have is 5 to the power 10 into 5 to the power 20 into 5 to the power 30 into 5 to the power 40 into 5 square whole to the power 50. This is going to be 5 to the power 10 plus 20 plus 30 plus 40 plus 2 into 50, which is 100. So definitely we are going to have more than 100 fives, which means more than 100 trailing zeros. So the answer is going to be 200 because that's the only value. वही एक option है जो 100 से ज़्यादा है. Anyways, if we add 10 plus 20 plus 30 plus 40, that is 100, and we will have another 100, so 200. Since there are 200 fives getting multiplied with way more than twos, we will get those many tens, and each 10 results in a trailing zero. 10 is made up of a single 2 and a 5. Right? So trailing zeros has to do with how many tens we have in a number, and tens are made up of twos and fives. We do not have to count the number of twos because number of twos are going to be way more than number of fives. Okay. 222 raised to 333 plus 333 raised to 222 is divisible by which of the following numbers? So 222 can be written as 2 into 111, and 111 is nothing but 3 into 37. Similarly, 333 can be written as 3 into 111, which can be written as 3 into 3 into 37. So if we have 222 raised to 333, this can be written as 2 into 3 into 37 raised to 333. And 333 can be written as 3 into 3 into 37 raised to 222. So the common numbers that we can take out are 3 and 37 here. Right? This will definitely be taken outside. We do not have to worry about the powers, reason being in the options we do not have powers. So we can see that it is going to be divisible by 3 and 37. So it can't be option A, it can't be option C, it's going to be B or D. Now, the difference between option B and D is that in option B, 2 is not permitted. In option D, 2 is also allowed. Let's see if we can take out 2 common. So 222, it's an even number. To the power anything will always result in an even number. Similarly, 333, it's an odd number, and 333 to the power anything, that is odd to the power anything, will result in odd. Now, when we add an even and odd, it results in an odd number. So if it results in an odd number, this entire sum will be odd. And if it is odd, it's not going to be divisible by 2. That is the very basic definition of an odd number. A number which is not divisible by 2, right? So and the answer is going to be option B. Next, what percent of water must be mixed with honey so as to gain 20% by selling the mixture at the cost price of honey? So 20% here is nothing but, we can write this as 20 out of 100, which can be written as 1 out of 5. Now, we have got honey, and in honey, if we add water, we will get honey plus water. So basically, the fraction that we see here, 5 denotes how much of honey we should have, and water denotes how much of water we are supposed to put. That 1 denotes that. So that finally we will have honey plus water, which is going to be 6. This is how we transform percentages to fractions and fractions to word changes. So the question asked is, what percent of water must be mixed? So we can see that so if there are 5 parts of honey, we need to add 1 part of water, which is 20% of it, to gain 20%. So basically, whatever percentage we see here, that's the exact percentage we should add. This is also known as adulteration. Next, what is the rightmost digit preceding the zeros in the value of 30 raised to 30? Well, these zeros are going to be found because of the 0 in the base. So if we ignore it, the question simply asked is, what is the rightmost digit of 3 raised to 30? Well, 3 raised to 30 can be written as 3 to the power 4 whole to the power 7. 4 into 7 is 28 into 3 square. Now 3 to the power 4 is a number that ends in 1, and to the power 7 into 9. Now 1 raised to 7 will end in 1, and when we multiply it with 9, our last digit or the rightmost digit is going to be 9. So had there been not 30 but only 3, the question was what is the rightmost digit or what is the units digit of that calculation. Next, 421 and 427 when divided by the same number leave the same remainder 1. How many numbers can be used as the divisor in order to get the same remainder as 1? So as per the question, 421, when divided by a number, it goes certain number of times and the remainder is 1. So this can be written as 420 is equal to D into Q1. Similarly, 427, when divided by a number, by the same number, it will go certain number of times and will have 1 as the remainder, which means 426 is going to be D into Q2. Now, if we subtract the first from the second, 426 minus 420 is 6. It can be written as D into Q2 minus Q1. So since D is written as a product of something and that equals to 6, that means D has to be a factor of 6. Now, the factors of 6 that we have are 6, 4, 3, 2, and 1. Sorry, 4 is not there. So it's going to be 6, 3, 2, and 1. So the divisor can be 6, it can be 3, it can be 2, but it cannot be 1. Why so? Why only 6, 3, 2, and not 1? The reason being, if we take a number, and if we divide it by 1, the remainder will never be 1. So the rule of division is that the remainder has to be always smaller than the divisors. Since the remainder is 1, so the divisor has to be greater than 1, which happens to be true in the case of 6, 3, and 2, all the 3 numbers. So the answer is going to be option C. Right? You can see that so far the questions may look difficult if someone has not prepared properly, but logic-wise or the steps involved-wise, they are pretty straightforward. If you keep a track of time from reading the question until answering it, it doesn't take more than 1.5 or 2 minutes. That's the max we take. Right? And that too while explanation is going on simultaneously. Next, a can X contains 399 liters of petrol and can Y contains 532 liters of diesel. They are to be bottled in bottles of equal size so that whole of petrol and diesel would be separately bottled. The bottle capacity in terms of liters is an integer. How many different bottle sizes are possible? Well, basically, if we ignore what kind of numbers are given, and if we think about that we have certain amount of petrol and we need to put it in bottles, what should be the volume of the bottles? It has to be less than the total petrol we have. Similarly, if we talk about the diesel part, whatever diesel we have, and if we pour it into bottles, the capacity of the bottle should be less than the total diesel we have. So we are thinking of numbers which are less than both of the given 399 and 532. Also, along with it, we need to find out where they both are same. So it should be common, it should be smaller value. Hence, we are talking about common factor, right? So we need to find out the common factors of 399 and 532. Now, in order to find that, let's find out the HCF. That will give us a fairly good idea. So if you look at 399 and 532, they are divisible by 3? No, they are not. Okay. Are they divisible by 13? They are not. So basically, we should start with this. Are they divisible by 2? They are not. Are they divisible by 3? No. Are they divisible by 5? No. Are they divisible by 7? So for 399, it's going to be 35 plus 49. So yes, it's divisible by 7. For 532, it's going to be 49 plus 42. Yes, it's also divisible by 7. So this is going to be 7 into 5, 35, 7 into 7, 49. 7 into 7, 49, and then we will have 42, so that is going to be 76. Now, are they divisible by 7 again? No, they are not. Are they divisible by 11? They are not. Are they divisible by 13? They are not. So basically 7 is the HCF here, right? So we can say that if I take 399 liters and if I pour them as 7 liters, so I will have 57 such bottles if the capacity of each bottle is 7 liters. Similarly, 532, if I say that I am going to have 7-liter bottles, then it can be poured into 76 bottles. So the bottles are of equal size and they are getting separately bottled, right? How many different bottle sizes are possible? That is what is being asked here, right? We need to take the further HCF of 57 and 76. So this is going to be 19 into 3, and this is going to be 19 into 4. So we see a 19 also. So instead of 7 bottles, we can also have bottles which have capacity of 19 liters, and there are going to be 21 bottles for this. And for the other one, we can again have 19 bottles, and it can have 19 liters, and the capacity is going to be 28 bottles. 19 liters capacity, 28 bottles required. So that is going to be there. We can also write this as 1 liter capacity and 399 bottles, and 1 liter capacity and 532 bottles. So if we had divided this further, this would have given us 19 into 3 is 57, 19 into 4 is 76. So 7, 19, and of course divisible by 1. So there are going to be 3 different bottle sizes that we can have. Well, in case if you have any queries related to any topic in mathematics or preparation or strategy or exam, feel free to ask me a question in the comment section. Okay, I'll get back to you with the response. Okay, I'll see you again with another session on this, where we will discuss previous year questions of CSAT from last year. Well, thank you for watching. Make sure that you subscribe to the channel, like and share the video.